you maybe have another question. If we want to build a road very long, more than 2 kilometers, how can we do that? So you should do control survey first. And usually, the control survey, of course, this is just the situation of China. The control survey usually accomplished by the people measuring survey and mapping. Yeah? It's not measuring civil engineering. So different people do different things. Yeah? So after then, accomplish the control survey, then we can do the engineering survey just for accomplish the structure, the road and the bridge and others. So this is a number 10 kilometers. 10 kilometers. The second is angle. Here is also given a table. In this table we say area 10 kilometers square and 100 kilometers square. The absolute area of angle you measured should be 0.05 second. Very small, yeah? And 100 kilometers square, the angle you survey, the error should be 0.5 second. You know, now in the world, the most precise instrument to survey the angle can just get this precise. So we say 100 kilometers square. This area, we can think of the surface of Earth as plane surface is resonant. In fact, 100 kilometers square is a great area, is a big area, yeah? Okay, so it's enough for normal engineer. And the third is elevation. If we say for distance and for angles, we have 10 kilometers and 100 kilometers and have these limits. But for elevation, it's different. Even in very small area, very short distance, we cannot ignore the error made by we think of the surface of Earth as the plane surface. For example, here, still this picture. From point A to point B, here, if we say this is the surface of Earth, so AC is a straight line in the plane surface. Here, if we want to get the elevation between 2 points, so we say here, from A to B, we say this is the real elevation difference. But if we think of the Earth's surface as plane surface, we must get the elevation difference from A to C. So this is obvious. The error is very big. Even in the distance, in the situation of distance, just only 0.1, that means 100 meters. The error should just 0.7 millimeter in elevation result. This cannot be ignored. So even in very short distance, the error will be very big. So for elevation survey, even in small area, the curvature of the Earth must be considered. We cannot, in any situation, think of the surface of Earth as a plane surface. But in real work, in real field work, sometimes this will is not take consideration because the instrument designed to get elevation difference will be do some operation to eliminate the error of this. Yeah, your observation. The instrument will do that work. Will do that work. Okay, this is three elements. One is distance, one is angles, and one is elevation. This formula we can forget that. Okay, we can ignore it. For distance and for angle, 10 kilometers, and for angle, 100 kilometers square. We can think of the surface of Earth as plane surface. But for elevation, even in very small area, in short distance, we must think the surface of Earth is curvature. Cannot think of that as plane surface. Yeah. Okay. This is the difference. This is the difference. Okay. For us, in this subject, we just talk about something in plane survey, not geodetic. But for some people measuring, surveying and mapping, they will do geodetic survey for the whole country. Very great, very big area. In this situation, you must consider the shape and the size of the Earth. And because the shape and the size of Earth is very complex, we cannot use a very simple math formula to express the surface of that. Yeah, very complex. Some mountain, some ocean, and some is very high and some is very low. Yeah, so we cannot use a very simple math formula to express the surface of the Earth. So in this in geodetic survey, sometimes we just we use a something to express that. And in this situation, you suited for control survey in large area, for example, a country. And in this situation, the distance, angles, measured are not on planes. That means in this situation, your geodetic survey, we can never think of the surface of Earth as plane surface. We must consider the curvature. But on the surface of spheroid of the Earth, okay, this is the geodetic survey. In most countries, they will classify the survey and mapping just two branches. One is geodetic survey and one is plane survey. Yeah, these two kinds. For engineering purpose, so we do plane survey, and for a country, so we do geodetic survey. For example, in geodetic surveying, when we do distance measurement from point Q1 to Q2, if we use the instrument to get the distance between these 2 points, so the result should be this right line. Yeah? Use the instrument to survey it and get the result directly. This is the right line, is the result get by the instrument. But when we do calculation, this right result is not suitable. We must use this here. The distance on the surface of Earth. So we must change this right to blue, and then change blue to green, and then green to the right. Yeah, this is geodetic. But for us, just for the engineering purpose, we can ignore the curvature of the Earth. We just think this right is a result. We can use it directly. Okay? in plane surface, in plane survey. And for example, for angle, for coordinate, if we do geodetic survey, so we think this surface of Earth is converged. So if we survey this triangle, and we say that these three interior angles, you added them, so the sum of them should be equal how much? Yeah? 180 degrees. Yeah? If we say on the plane surface, of course, the sum of them should be equal 180 degrees. But if the surface is not plane surface, it's the converged surface, so the sum of them is more than 180 degrees. Yeah? So we must do some calculation and then project the angle from the converged surface of Earth to the plane surface. So we must do very complex computation, calculation. Yeah? So this is the difference of plane survey and geodetic survey. If we use another criteria, use the function of survey, we can classify by the functions of survey into many different branches. First is construction surveys. We also call them engineering surveys, and topographic surveys, and route surveys, and spatial surveys, and ocean surveys, and many others. Of course, in our subject, we just learned engineering survey and some part of topographic survey. Okay, you just know that. And for example, for construction, so we use some instrument to determine the location of points of design on the map and find the real position on the ground and make mark to tell others where to build the building. Yeah, build the building. And for topographic survey, the main purpose, the main function is to get the map. Get what map? Usually, in normal days, every day when you do some traveling, you will never use this map to tutor to the scene. Yeah, I mean, in normal days we will not use this kind of map. Yeah, all lines, and we cannot find beautiful thing on the map. Yeah. This is topographic map. We say, in this map, we can know the elevation of points and many things, anything of real world will show expressed in this map. But when you use the paper to do some traveling, then the traveling map is just to show you where is the bus station and where is the ticket office, yeah, like that. It's different, and the route survey sometimes like this. Yeah, you say this is dormitory. Yeah, oh, no. This is dormitory. Yeah, here this is home, the place. And this is just drawn by the student actually surveying and mapping. Yeah, okay. And we say this map we say is the topographic map in digital shape. Yeah, okay, drawn by the CAD, And for route survey, just to say we survey some area for build a road, a railway. Then in that situation, we do route surveys, and sometimes we do some special survey. Okay, of course. In broad sense, survey branches also can include photogrammetry, remote sensing, marine surveying, and cartography, and sometimes some mapping, engineering, and sometimes even sometimes the science of bridge. Yeah. Okay. This is the task and the branches, and then if we want to do survey in some certain area, we must obey some basic principles. First is do control survey, then do detailed survey. That means control survey first, then detailed survey. Detailed survey. In this picture, we say here we have some building. If we want to do survey to get a topographic map for this area, you cannot use the instrument from this corner survey and then just from here, from this corner and to this corner directly. Why? If you use instrument to survey this corner, this area, and then this area, then this area, and from here to that place directly, you see the result we want. Maybe make big arrow, yeah? Because each step will make arrow, yeah? So from here, if we make an arrow, we do not correct. So here, maybe make it even more big arrow. So you must do control survey first. That means around this here and around this area, we must determine some control points. For example, here 1, 2, 3, 4, 5, 6. These points we say is control points. Firstly, we use some special method, survey, and get the coordinates of these control points precisely. And then, based of the coordinates of control points, we do detailed survey around these control points. Yeah, for example, if we do control survey firstly, get the coordinate of these points and the coordinate of this point because it's control point. So the coordinate is precise. The error is very small. It is small. And for these control points, the error should be equal roughly. And the error is very small. Then we base on these control points and use instrument to survey the area, small area, just around this control point. So this area around this point, control points, this area just around this control points, and divide this big area into many small areas, and then each small area we do detailed survey for the shape of the building, for the shape of the hill, for the shape of other features on the surface, on the ground. Yeah? And in these two steps, first we do high precise for the control survey, and we used low precise but more effective survey to do detailed survey. Yeah? So we can both get precise result and we can more effective work. Yeah? But if we just do survey directly from this corner, just straight to that, so we make a big error. And this is one point. Another point is, for example, we have many students. So we do graph training. If we just, all 20 people just from this survey to that. So we must from here to that place. But we do control points firstly. Maybe we can divide into many groups. Yeah? We can do this work together. So one group in charge of this area, another group in charge of this area. Yeah? We can do cooperation. Yeah? Cooperation. So this is two steps. Firstly, do control survey, and then do detailed survey. If you do detailed survey directly, maybe you can get a wrong result. Okay, we have